Okay, good afternoon, friends. I'm audible to all of you. And also let me know whether this presentation is also visible.
Yes, sir.
Yes, sir.
Okay. So I think in the last lecture we have just started with the concept of RMS and average value. Have we calculated the RMS value of a sine waveform? Please let me know.
Yes, sir.
Okay. And what about the definitions of peak factor or crest factor and form factor? That is also over. Okay, I think we have started with some numericals, right? Okay, this numerical we have solved as much I remember. Now I got it. Have you solved this numerical? Please check.
Yes, sir.
Now let us try to solve the next one in sequence. I will try to consider this numerical. So this also has been asked in the latest semester paper, that is summer 2019. So this is the text of the numerical that has been given. So now what we have to find out? We have to find out the time required by the current from t is equal to 0. That means this is, for this point I have taken it as a reference now. So from this point, within how much time the current will reach to a magnitude of 6 ampere plus 6 ampere. That means they want us to calculate the value of current or when it will become equal to plus 6 ampere. For the first time, that means we have to calculate the value of time period at which the current will become equal to 6 ampere. So first of all, the current will flow through the positive half cycle, then it will complete its negative half cycle, and again the positive half cycle will start. So at two instances, the current will become equal to plus 6 ampere. First time it will become equal to plus 6 ampere in the first positive half cycle, then it will complete the negative half cycle, and again the positive half cycle will start. So once again in the second positive half cycle, the current will attain a value of plus 6 ampere. So at two time periods or at two time instances, we need to calculate or when the current will become equal to 6 ampere. So let us try to see how we can solve the first part of the numerical. So this is the standard equation for the current. I of t is equal to Im sine omega t1. Now specifically I have written this as t1 because at two instances I need to calculate the current value equal to 6 ampere. So when the current will become equal to plus 6 ampere for the first time, I have denoted that time as t1 seconds. So will anyone let me know how much will be the answer for t1? What you need? Any another information do you require over here? So can you calculate the frequency value first? Okay, so if I simplify this equation further, then we can calculate the frequency value, which will come out to be equal to 149.92 hertz. So omega, its value is 942. We know omega is equal to 2 pi into f. So from this equation or expression for omega, first of all, we need to calculate the value of frequency. And then we need to calculate how much time will be required by the current to achieve a value of plus 6 ampere for the first time. So here I have substituted I of t equal to plus 6, and this angle I need to substitute in degrees, that is the value of pi. So I have substituted it in degrees. So it is 180 degrees, that is equal to pi radians. So now I can calculate the value of T1. So value of T1, if you calculate it, you will get it equal to 6.83 into 10 raised to minus 4 or 0.683 into 10 raised to minus 3 seconds. So after or at this particular time, the current will attain plus 6 ampere value for the first time. So it is somewhat similar to the previous numerical that we have solved at the end of our last session. And now we have to calculate the amount of time required by the same current to once again attain plus 6 ampere for the second time. So let us try to see how we can calculate this value. So the current will once again will be equal to plus 6 ampere after completing one cycle. So first of all, we need to determine the amount of time required to complete one cycle. So that time period t, it is the inverse of frequency. So it will come out to be equal to 6.67 into 10 raised to minus 3. This sign should be minus. I have forgotten to place that minus sign over here, but you can easily calculate this. So within this much time, the current will able to complete its one complete cycle, and then its positive half cycle will start. And therefore, the time taken by the current once again to become equal to plus 6 ampere, that will be t plus t1. So if you put the values over here, you will get the answer as 7.353 into 10 raised to minus 3 seconds. So please check whether you are also getting the same values or not, so that we can proceed further. So the final value of t, it is 7.353 into 10 raised to minus 3 seconds. So after or at this particular time, once again, the current will become equal to 6 ampere. So this is how we can solve the numerical and we can get the desired or the expected answer. Okay, now this numerical will solve, and then we will start with the next type of numerical. So I request all of you once again to copy down this numerical, which is visible currently on your screen. So we have already seen what is the definition of form factor and peak factor. So this numerical is based upon that particular concept. So as you can see, we are supposed to calculate the value of frequency, value of the form factor, and value of the crest factor. So even though we know for a sine wave, the value of form factor and peak factor, they are fixed. But once again, even though we know it, we have to calculate it using the formula. So first of all, we have to calculate the frequency which I have asked in first part of the numerical. So value of omega, that is 2 pi into f, it is equal to 314, and therefore omega is equal to 2 pi f, that is equal to 314. So if I solve it for solve it for frequency f, then the answer will be approximately equal to 50 Hertz. Actual answer is 49.99. So I have rounded it off to the next integer, that is 50 Hertz. So this is the first part that is required in the numerical, and now we can calculate the form factor. So for an alternating quantity, the form factor, it is the ratio of RMS value to the average value. So maximum value they have given it over here, that is 200 volt. So we know the RMS value, we already calculated the RMS and average value for a sinusoidal waveform, and as you can see, this expression clearly indicates it is a sinusoidal wave, and therefore RMS value, it is maximum value upon the root 2. So the answer will come out to be 141.42 volts, and average value, as we have calculated it earlier, it is 0.636 into Vm. So it will come out to be 127.32. And now we can take the ratio of both these values, that is RMS to average. So answer will be approximately equal to 1.11. So we already know the value of form factor for a sinusoidal wave. It is 1.11. That is the standard value. Still, it is required for us to solve it by using the formula. So if you write down directly the value of form factor is 1.11, you may lose some of the marks because you might have not followed the proper approach. So this is how we can determine the form factor, that is Kf, and the peak factor, as we know, it is the ratio of maximum value upon RMS value. So that is 200 upon 141.32. So answer will be equal to 1.414. So this is how we can calculate the RMS and form factor and peak factor for the given condition. So whether these two numericals are clear to all of you?
Yes, sir.
Okay. Okay, now we'll try to find out the average and RMS value for this particular waveform. So this I have taken from, once again, from one of your previous semester paper, that is summer 2018. So before we proceed, let me know whether this waveform is symmetrical or asymmetrical waveform.
Symmetrical.
So for a symmetrical waveform, to calculate its average value, we are supposed to consider only the half cycle and not the full cycle. As you can see, this waveform, it is representing the waveform for a current, because on y-axis they have plotted the current, that is Im they have given, that means it is indicating a waveform of a current. And as the waveform is symmetrical, we will consider only half cycle of the current waveform. So this current, it is completing its one cycle within a time period of 2 pi radians or 360 degrees. So half cycle will be covered from 0 up to pi radians. That means the integration limits for calculation of the half cycle, for calculation of the average value will be from 0 to pi. But first of all, we need to write down the equation for this waveform. As it is not a sinusoidal wave, it looks like it is a square wave. So first of all, we need to write down the equation for this current waveform for the full cycle. Okay, so let us try to see how can we write down the expression for the current. So what will be the equation for this line which is parallel to your x-axis? As you can see, the current is having some non-zero positive value initially. So it will travel with the same value, and at time period equal to pi radian, the current value will suddenly decrease to 0, and there onwards its negative half cycle will start. So to write down the equation for the given waveform, if the waveform is like this, first of all, I need to write down the equation for this first section. So what is the equation for a line which is parallel to your x-axis? So the equation will be I is equal to Im for a time period of 0 less than theta, because on x-axis they have shown the parameter as theta, that is equal to omega t. So the equation for this straight line which is parallel to your x-axis, it can be written as I of t equal to Im for a time period of 0 less than theta less than pi. So while solving or calculating the average value for this particular waveform, now I have to substitute, as you can see, the expression for I of theta. So as it is a symmetrical waveform, we are supposed to consider only the half cycle of the waveform, and therefore I have written it accordingly. It is 1 upon time period required to complete the half cycle. So it will be 1 upon pi integration from 0 to pi of I of theta d theta. Now I theta we know it is equal to Im. Just now we have written the equation for it, and now we have to solve it further. So will any one of you will solve it and let me know what is the final answer that you may get if you solve it. Now what next you have to do? It is a part that you have studied in your 12th, integration part. So it has no resemblance with the electrical engineering. So my meaning behind this is you can now calculate the remaining part because it is related to mathematics only. So please calculate the value of I average and let me know what answer you are getting at the end.
Im.
I is equal to Im. So average value of the current which is given by that square waveform, that is equal to Im ampere. And now we have to calculate the RMS value. So RMS value, it is root mean square. So this is the first time that we are calculating this. So it will be square root of 1 over pi integration from 0 to pi of I square theta d theta. That means here I have squared the current. So now I have to substitute I of theta equal to Im. So if I do that up to this particular step, now I have simplified it. I request someone of you once again to calculate the value of IRMS and let me know what is the answer.
It's again Im.
Again it is Im. Okay. So all of you are getting same values.
Yes.
Okay. Now let us try to solve this. Now this will let me know whether you are able to determine the equation for a line. Now as you can see, first of all let me know, is it symmetrical or unsymmetrical? Unsymmetrical, because there is no negative half cycle present which is exactly equal to the positive half cycle. Anyhow, even though it is asymmetrical, the only difference that we need to make is instead of considering the time period for a half cycle, we have to consider the full cycle. Now, what are the limits of the full cycle of this particular waveform? That means what are the x coordinates within which the current or the concerned wave, it is completing its one cycle. As you can see, the current has started its journey from 0. It has increased with a particular slope equal to 20 ampere. Then it has reduced to 0 again. Then it is still equal to 0. And at this particular point, once again, it has started increasing up to the same value, that is 20. So what are the limits, or within how much time the current is completing its one cycle?
0 and 4.
0 and 4. Okay. So even though the time required to complete one cycle by the current, it is 0 to 4 seconds, still between 0 to 2, the current is having a different type of waveform, and from 2 to 4, the current is having some another type of waveform. That means from 0 to 2, the current is gradually increasing up to 20 ampere, and from 2 to 4, the current is having a 0 value. So first of all, we need to write down the equation for this line between the limits 0 to 2. So what is the equation, or how can we write down the equation of a line which is having some slope? It is not parallel to your x-axis now. I am talking about the line segment between 0 to 2. So what is the equation for the line which is starting from origin and having some inclination with the x-axis? What is the standard format of straight line equation? Y is equal to mx minus c, no? Or mx plus c?
Mx plus
mx
c.
plus c. So what is that c stands for? And what is the meaning of that m?
M is the slope.
Okay, m is the slope. And what is c? Because if you are saying straight line equation, it is y is equal to mx plus c, then we can easily calculate the value of m. But what about c? What is that c, or how much will be the value of c if the line is starting from origin?
Y-intercept.
Okay, it is y-intercept. So in the present case, as the line is starting from 0, y-intercept is 0. That means value of c for a time period of 0 to 2, that is equal to 0. So can you determine how much is the slope of this particular line segment from 0 to 2?
10.
10. So what is going to be the equation for the line for the segment from 0 to 2?
Y equals 10x.
Why is it? Okay, sorry, I got a mistake. Okay, I will just recommend one thing. Instead of this 20, consider it as 40, because I have calculated by mistake the slope as 20. So please make this value as 40 so that remaining calculations will match with mine answers. Okay, so please make this magnitude on y-axis as 40 instead of 20 over here. I don't know how I substituted it as 20. I might have calculated the slope correctly, but while putting it over here, I have gone wrong. And here onwards, I have taken this value as the equation for the line. So please make a change this 20 equal to 40, so that slope of the line will be equal to 20 and you will get the same equation. So have you understood what correction or what rectification you are supposed to make now? Please change this value from 20 to 40 so that remaining things will match with my answer, because here onwards I have calculated the things considering the equation as 20t, and therefore I request all of you to make this value as 40 instead of 20. Now the waveform is not symmetrical, so we are supposed to cover or consider the full cycle. Now from 2 to 4, what is going to be the equation of the line? It will be equal to 0, as you can see it over here. So that means one cycle of the given waveform, it is divided into two parts. For a period of 0 to 2, it is having one equation. For a period of 2 to 4, it is having some another value. So from 0 to 4, it is going to complete its one cycle. So these are going to be our integration limits. Lower limit is going to be 0. Upper limit is going to be 4. And we have to consider the full cycle of the given waveform. So let us try to see how can we calculate the average value first. So let me display all the things, or we'll calculate RMS value and then we'll go for average. No problem in that. Anyhow, we have to solve it fully. So this is the formula for RMS value. It is 1 over T, where T it is the time period required to complete one cycle. Integration limits are decided looking at the time required to complete one cycle by the alternating quantity and I square T dt. Now this current, as we have seen, it is having two parts. From 0 to 2, it is having one value. From 2 to 4, it is having some other value, and therefore these integration limits I have to state according to the waveform. So as you can see, first segment I have written it is from 0 to 2. This is the equation for the current for the time period 0 to 2, and this is the value of the current for a time period 2 to 4. So I have splitted the integration limits according to the waveform, and then now I have to solve it further. So are you able to solve it by your own here onwards, or do you need any help from my side? I am asking you people to carry out this activity because this is a part which is related to mathematics, and therefore nothing much is required, I think, for you to suggest or for you to help out over here. So if you are comfortable with integration, you can easily solve it further. So please let me know, is there any need for me to display the next steps, or you are able to solve it by your own? Okay, for those who are not able to carry out the calculations further, I will just display all the steps. One who is able to solve it by his or her own, you may cross check it and then let me know whether whatever presented at the end, it is correct or not. I am getting the value at 16.32. Please check whether you are also getting the same value or not.
Yes, sir.
Yes,
Same
sir.
value.
Okay, same value, fine. So this is how we can calculate the RMS value. Let us try to calculate the average value. Now up to first two steps I will explain. Now remember, we are calculating the average value as the waveform is unsymmetrical. We have to consider the full cycle. So here I have substituted the integration limits of the full cycle, that is from 0 to 4, and it is 1 over t, where t it is the time required for your cycle to complete one wave or one cycle. So again I have to split the integration limits. So I splitted them on the next step. And now once again I request to calculate this part here onwards and let me know what answer you are getting at the end. How many amperes?
10 ampere.
10 amperes. So I am also getting the same value. So this is what I have carried out the calculation further. I hope all of you are aware about the thing, how to get or how much is the value for integration of t dt. It is t square by 2. Here it was t square dt, so its integration is t cube by 3. So anyone having any difficulty with this numerical, or is it clear? Once again I repeat, or I will tell you the correction that is required to be made in the numerical so that your answers will match. Change this 20 equal to 40. That is the basic change which is required to be made in the numerical. Otherwise, you may try to consider the correct value as it is 20, and that means here instead of 20t it will be 10t, and then you can carry out the calculation further. So here for this numerical, it is my mistake that I forgot to consider it as 20. I consider it as 40, and therefore I have calculated or written the equation for the line as 20t, which should be ideally 10t. But anyhow, by changing this value to 40, we are going to get the same answers, and therefore I request all of you to please change this 20 by 40 so that you will get the same answers at the end. Okay, now let us try to solve this. This is also from one of your previous semester paper. So again tell me, is it a symmetrical waveform or an unsymmetrical waveform?
Unsymmetrical.
Unsymmetrical waveform, okay. So what is the time required to complete one cycle by the given waveform?
0 to 4.
0 to 4 once
4
again.
seconds.
Okay. So for a period from 0 to 2, the voltage now they have given on the y-axis, they have shown it as V of t. That means it is a waveform for a voltage. So from a period 0 to 2, the voltage is increasing linearly with a particular slope. Then when time becomes equal to 2, the current suddenly drops down to -1. And then from 2 to 4, once again, the current continues its journey with value as -4. So now this particular section which I have highlighted, it is representing one cycle of the voltage wave. As the waveform is not symmetrical, we have to consider the full cycle, and first of all, we need to write down the equation for the voltage from a time period of 0 to 2 and then from 2 to 4. So will you please solve this now and let me know what is the answer you are getting at the end? What is going to be the equation for the line for the time period 0 to 2?
Y equals X.
Y equal to
X.
X. So what is X? What they have plotted on X axis? It is the time T.
Yes.
Okay, so for the section 0 to 2, the equation of the line will be V of t equal to T only, because on y-axis they have plotted voltage, on x-axis they have indicated it as a time. So equation for the line for a time period of 0 to 2 will be V of t equal to T only. And what about the time period from 2 to 4? What will be the expression for the voltage?
V of t equals -1.
V of t is equal to -1. So will you please try to calculate the average and RMS value by your own?
So the slope is changing in the other cycles.
Sorry, you are not clearly audible to me. So please check the connectivity at your end.
Sir, the slope is changing in the other cycles.
No, no, no. It is my mistake to represent the waveform. The slope is same. Same cycle has been repeated. Okay, now I got what exactly you want to say. You want to say that this side and this side is different. It is not like that. It is my mistake that I made while drawing the waveform. The slope is same. So don't get confused. The same part, this part is getting repeated continuously. So the slope is same everywhere. So please carry out the calculation by your own, because once the moment you could able to write down the equation for the given waveform, only thing is just you have to put the proper integration limits and solve it further. So I do have made the calculations at my end. So I'm waiting for an answer from your side now.
Sir, RMS is 8 ampere.
Now please check it once again. What expression you have written for RMS value? It is square root of 1 upon 4, because time period required to complete one cycle is 4. Integration from 0 to t of t dt. Am I right? Integration from 0 to 2 of t dt plus integration from 2 to 4 of -1 square. So -1 square will be equal to 1. So it will be integration from 2 to 4 of dt. Am I right? What I said? Okay, anyone getting some another answer? One answer that I got is 8 ampere or 8 volt. Actually, it is not ampere now, it is a waveform for a voltage. So one answer that I got is 8. Anyone else getting some another answer? I am getting the answer as 1.08 volt. Anyone else getting the same answer, 1.08? Are you able to carry out the calculations by your own? Because no one is giving me any answer. I am asking a number of questions. I already asked them.
Sir, what is V average?
V average will be equal to 1 over T integration from 0 to 4 of T dt plus integration from 2 to 4 of minus dt. So if you solve it, it will be 1 by 4 integration of what value you are getting. Please let me know so that I can check it instead of repeating each and every step. What answer you are getting? Only one student is giving me some response. I don't know what has happened with others, whether they're not at all interested or they have simply joined the meeting and they have left now. That means they are away from their cell phone. Okay, I am getting the average value as minus 1.5. Are you getting the same answer?
So I got -2.
Minus 2. What are the terms that you have written inside the integration? From 0 to 2, it is T dt. Am I right?
Yes, sir.
And from 2 to 4, it is minus of dt or minus 1 dt. So it will be t square by 2 and that 1 by 4 is still outside. Okay, let me check. I think I have gone wrong it over here. Okay, it is minus 2. I have gone wrong. Okay, what about other students? So I have not displayed anything related to this numerical because I just want to check how many of you are seriously solving the numericals and how many of you are just waiting that something will get displayed on the screen. So purposely I am not at all going to display it also anything on the screen related to this numerical except the waveform, and I have already provided you the assistance that is required. Okay. Now, okay, this is the first numerical of this particular type. So let us try to calculate it. So please have this numerical or this waveform in your notebook now. And let me know whether it is a symmetrical waveform or it is asymmetrical or unsymmetrical waveform. and how much time is going to be required by the current, as they have plotted current on the y-axis. So we can say it is representing a current waveform. So how much time is required for the current to complete one cycle? Actually, they are not given us another cycle, whether it is repeating one or not. But we can say that this current, once again, it will start increasing in the same fashion as it has increased from 0 up to 2 pi. So whether it is symmetrical or asymmetrical waveform, it is a symmetrical waveform, and therefore to calculate the average value, we are supposed to consider the full cycle of it. So now I have to write down the equation for the current. As you can see, the current is having one pattern from 0 to pi and some another value from pi to 2 pi. So that means the given waveform, it is divided into two different segments. From 0 to pi, the equation of the current can be written as Im sine of omega t, and from pi to 2 pi, as its value is reduced to 0, so it will be equal to 0 for a time period of pi to 2 pi. So this is how we can write down the equation for the current by looking at the given waveform or given cycle. Now time required to complete one cycle, it is from 0 to 2 pi, and as it is unsymmetrical waveform, we have to consider the full cycle. So let us try to calculate the RMS value first. So as you can see, it is 1 by t, that is the time required to complete one cycle, integration from 0 to 2 pi of I square d omega t. I have considered it as d omega t because here the x coordinate they have shown as it is omega t. So now I can substitute the expression for the current for the two different time periods. From 0 to pi, its expression is Im sine omega t. From pi to 2 pi, its value is 0. So I have splitted the integration limits into two different segments. So now I can simplify this further. So as you can see, it will be Im square sine square omega t dt for the integration limits as 0 to pi. So we know what we have to substitute instead of sine square omega t. So it is 1 minus cos 2 omega t upon 2. So I have carried out that substitution further. Will anyone simplify this and let me know what answer we can get at the end? So if I substitute, or if I first of all carry out the integration, then upon integrating the things, this is what we can write down. Second term, its value will be 0, so there is no need to consider anything related to the second part of this current expression. So this is how we can carry out the integration of this entire term. So I have not taken these two outside, I have still retained it inside the square bracket. So there is no reason behind this. It is just a matter of simplicity that I feel instead of taking these two outside and then making the things complicated, let us keep it here itself. Later on we can simplify it further. Now just I have to put the integration limits. So that activity also I have carried it out. So first upper limit I have substituted. So it is pi by 2 minus sine of 2 pi upon 4 minus 0 by 2 minus of minus, that will become plus. So it is plus sine of 0 by 4. So if you simplify it further, as you can see, how much is the value of sine 2 pi or sine 360?
0.
0. So it will only have Im square by 2 pi into pi by 2. So pi will get cancelled. So inside the square root sign, we will have only Im square by 4. So how much is going to be the RMS value then? Is it equal to 0.5 amperes, sorry, 0.5 Im?
Yes.
Okay. And now we can go for calculation of average value. Now I don't think there will be any problem to any one of you regarding this integration, as nothing complicated is involved. As you can see, once again I have considered the full time period or time required to complete the full cycle as the waveform is unsymmetrical one, and then I have substituted the proper integration limits and the proper expression for the given waveform according to the integration limits. So now you can, or you have to simplify only this highlighted term, as second term is already equal to 0. So now at least solve this and let me know what answer you are getting at the end.
Zero point 318.
0.318 IM. So I am also getting the same answer, as you can see. Okay. Anyone is having any doubt? See, if you observe all these numericals carefully, you will notice that if you are comfortable enough to calculate the integration of sine and sine square, sine of omega t or sine of theta and sine square theta, then no additional knowledge is required to solve such type of numericals. And obviously some knowledge is required about writing down the equation of the waveform. So these numericals are not that much difficult, but you need to have enough practice of solving such type of numericals. And purposely I am considering all the numericals that have been asked in previous semester paper, so that you people will also get some confidence that we also can solve the numericals that are being asked normally in the examination. So that is my main intention behind considering the numericals from the end semester papers. Otherwise, lot many numericals are available almost everywhere. You may search them on the internet, you may refer any textbook or any another thing. So everywhere you will find out variety of numerical based upon calculation of RMS and average value. But I just want to boost up some confidence in your mind, and therefore I am focusing only on the numericals from previous semester paper. Now this is the complicated one, and therefore I request all of you to please pay proper attention on this numerical. So therefore I request all of you to have this particular waveform in your notebook. Please be careful about the integration limits, and they have given only this much part of the waveform, so we cannot say that whether same pattern is going to get repeated in the positive upcycle or this waveform may have a negative upcycle. Nothing they have given, so only this much part of the waveform they have given. So there is no point about discussing whether it is a symmetrical or asymmetrical waveform. As it is, we have to consider it. So just complete the diagram and let me know once you finish with this. Probably this will be our last numerical for today's session. So please complete this activity. That means you are supposed to draw the waveform along with the proper coordinates, both x coordinate and y coordinate. And now at least inform me that yes, we have completed or we have drawn the circuit or drawn the waveform in our notebook. So in how many sections the given waveform is divided, if you look at the waveform carefully, or the waveform is having same pattern from 0 to pi. That solid part of the waveform, it is the actual waveform. Dotted segment I have represented only for explanation purpose. So dotted segment, it is not a part of the given waveform. Your actual waveform, it is starting from 0. It is increasing in a particular manner till it becomes equal to 0.866 Vm. Then it is continuous journey parallel to the x-axis up to this particular point, and then it has or it will achieve the maximum value, and again it will continue journey once again in a specific manner. So this particular section, it is not a part of your given waveform. So how many segments are there, or in how many segments this given waveform is divided, or is it having same pattern for the entire time period, that is 0 to pi? Okay, so as we can see, the waveform is divided into three sections. From 0 to pi by 3, the waveform is increasing according to a particular equation. From pi by 3 up to pi by 2, the waveform is constant, or it is a line parallel to the x-axis, that is, it is a constant value. And from pi by 2 up to pi radians, it is having, or it is following another pattern. So as we can see, if I complete, or if I try to join these 2 points, I will came to know that it is nothing but part of a sine wave. That means from 0 to pi by 3, the waveform is increasing, or that voltage is increasing according to sine function. From pi by 2 up to pi, the waveform is decreasing according to the sine function. And from pi by 3 to pi by 2, it is having a constant value. So this given waveform or its mathematical expressions can be written into three different sections, as I have written them over here. So from 0 to pi by 3, it is following a sine rule. From pi by 3 to pi by 2, it is having a constant magnitude of 0.866 Vm. And from pi by 2 up to pi, once again it is following a sine rule. So that's why this numerical is little bit complicated, and therefore as you can see, the weightage is also more. It is asked for 10 marks. So now 40% of the numerical we have completed. Just we have to put the proper integration limits and the proper expressions within the integration limits and carry out the simplification further. So let us try to calculate the RMS value first. So this is the expression for the RMS value. So now I have to just substitute the various expressions for the voltage and the proper integration limits. So I have substituted them over here, and then you can solve it further. So I have substituted the proper expressions, and then I have calculated the further simplification part also. So once again, as you can see, just you need to know what is the substitution for sine square of theta. So if you know that, then remaining part, it is comparatively easy. Just you have to carry out the proper integration and solve it further. So I have simplified it further. So here I have carried out the integration of all the terms which are present over here. And now if I substitute the proper integration limits, and if I continue my calculation further, this is what I am getting at the end. VRMS, it is coming out to be equal to 0.687. So please check whether you are also getting the same value or not. If you are getting the same value, it is fine. Otherwise, in the next lecture, I will first ask all of you whether you have obtained the same value or not, and then calculation of the RMS value, I give it as a homework to all of you. So those who are interested, they may try to get the average value by their own. Those who are not interested, it is up to them whether to solve the numericals by your own or not. So with this, for today's session, we'll stop at this particular instant. Next time when we'll meet, we'll continue our discussion with the calculation of RMS value for the same waveform. So for today's session,